Good morning. Yes, it's cold out there. I thought this is spring, but it doesn't feel like spring. I'm coming from California. I flew in last night. It took me a little longer to fly in. And talking about flying, they seem to be sending me to cold places on a regular basis. Because a few weeks ago, I was flying into Oslo, and we were landing, and the pilot announces it's -6 degrees and freezing fog has rolled in. And I was, okay, what does that mean? He's like, well, we're going to try landing, but if we don't make it this time, we have 45 more minutes of fuel to keep trying. So I was like, what happens after? But hopefully it's not that cold out here. So I'm going to talk a little bit about features. So I just have to say this, don't make your purchase decisions based on anything I say, but most of the stuff that we're going to talk about is there today. So, it's an exciting time to be a developer, following up on what Ken had said around Java 10, et cetera. But one, serverless programming is becoming really popular, which is how do you spin up instances on demand. But as you think about these, you now have to think about distributed programming. You have to think about taking events off. You have to think about how to synchronize the data storage, et cetera. Chatbots, now bots are becoming really, really, the buzzword out there as the user interface. But as you think about bots, you have to think about natural language processing. You have to think about AI, maintaining the state and context of a conversation. So it's becoming hard for developers. DevOps has been wonderful. It has improved our productivity significantly. But now what we're finding is that developers are spending 40 to 60% of their time in just doing DevOps, setting up Jenkins, setting up the various parts of a CI/CD pipeline, figuring out how to get Kubernetes going, et cetera. How do we move towards NoOps, where you get the benefits of DevOps, but with less work done by the developer, so the developer can focus more on writing code? Blockchain. Everyone's talking about blockchain. Not everyone knows what blockchain is. And the key thing is which use cases in production will actually result in value for the business organization. That's really important to figure out before we go start implementing Hyperledger. Open source. Open source is wonderful. Lots of innovation going on in open source. When we think about Kubernetes, which is used for orchestration, Kubernetes releases every 6 weeks. How do you upgrade Kubernetes? How do you set up Kubernetes? How do you scale Kubernetes? Getting etcd in front of Kubernetes for high availability, et cetera. You end up spending a lot of time doing that just so you can write your programs that can run in containers that might give you portability or that might give you better functionality. So how do we reduce the work effort there for developers? And then the last one is machine learning. Today, if I didn't mention AI and machine learning, then my talk would absolutely be useless. So let's talk about machine learning. The key thing for developers is, one, how do you get the platform to give you AI built in? And two, how can you embed machine learning into your applications without necessarily being a data scientist, without needing to understand machine learning, and making it very domain specific? So these are some of the things that we're going to talk about is how do we make the life of developers easy as we go down this path. And I'm not going to talk that much about the Oracle Cloud Platform, but we have a platform where you can develop your applications written in any programming languages, deploy them, run them, scale them based on containers. We have the ability to integrate SaaS applications to SaaS applications, SaaS to on-prem, and on-prem to on-prem applications. So as you're writing your custom applications, how do you integrate those applications, other pieces of packaged applications that are there? To be able to publish your content, to be able to secure the content, to be able to analyze and predict. So how in your applications can you embed functionality so you can be looking at data, analyzing data, and being able to help your users of your applications be able to predict? And finally, security, security and manageability. How can you monitor and manage from the cloud without needing to worry about installing monitoring and management tools and aggregating log data, performance data, user experience data without worrying about where that stuff is stored, and securing, making sure there's single sign-on, et cetera. So that's the Oracle Cloud Platform. But before I get into the demos that I wanted to show, which was around serverless and functions and blockchain, we did have an interesting announcement. And that's around GRAIL VM. So with that, I'd love to welcome Eric Sedler, who runs engineering for GRAIL. Eric?
Thanks.
Let's talk a little bit about GRAIL. So first, what is GRAIL? Not everyone knows what GRAIL is.
OK, so thanks. So GRAIL is a multilingual, embeddable efficient language virtual machine. And so the vision that we have for this project, which we've been working on in the labs for about 7 years now, is that you write your code once in whatever language you want, and then you can use it in any application written in any other language and run it in whatever engine you want to. So you can run it in Java Hotspot, you can run it in Node, you could run it in MySQL or the Oracle database, or you can just run it standalone in a container. It's already in production in some Oracle products like OPA, and but the big public website that we're on is on Twitter. So all the tweets that you're tweeting on during this conference are going through GRAIL VM today. And
wow.
There are a lot more things in progress.
No, so what about GRAIL makes it special that makes Twitter use GRAIL? What's the underlying architecture around GRAIL?
So the architecture for GRAIL is one where rather than designing the language runtime specifically for a particular language, like designing it for Java or for JavaScript, we designed it kind of one level meta. So it's running things that run languages. And it's kind of a part of a larger trend in the history of virtualizing software. And one of the reasons that we've done that is to have this idea that Java introduced back in the 90s of write once, run anywhere. And what that actually meant was what I'll call hardware level virtualization. It means you can run your app on any processor regardless of the ISA, and that was what Java tried to do, and then Microsoft came along with CLR. And then there's a next step in virtualization that you'd see with VirtualBox or VMware or whatever, where you can run your app on any operating system regardless of what you had installed on the hardware, and that was another level of convenience. But today, if you write your code in Java and then you want to put your Fortran app on it or vice versa, like Ken does, you're kind of in trouble. We actually would allow Ken to do that because you can run Fortran on our LLVM interpreter and then run a Ruby front end or a JavaScript front end or a Java front end on it. And so what GRAIL does is it watches the interpreters, which have taken the front ends of all these different languages. We ported them to our API, and then what GRAIL does is it watches what the API does, learns the language semantics, and then generates a compiler for it. And all that stuff can be linked together with zero cost overhead to go between languages. And you can make any memory structure so foreign objects can look like the native local objects to avoid an allocate and copy. And then all that stuff can run in any of the engines I mentioned there along the bottom. And standalone, you can compile ahead of time, which gives you fast startup and low footprint rather than running another VM.
Well, no, it sounds pretty cool, pretty awesome, but I'm not sure that we should sell this on the basis of it can run Fortran for you.
Yeah. Well, I tried to tie it into the earlier keynote here, right?
No, that's good. That's wonderful. Very creative. And where should people go to see, what's going on with GRAIL?
Well, so GRAIL is actually one of the, it's a big community effort. So it was built in the open. There, you can see here.
And stay close to the mic, please.
Oh, yeah. So I don't know if this is going to work. No, the pointer is not.
No, just point here.
Oh, point here.
And put it in this little dot here. There.
Okay, great. 24,000 commits, right? And we've got 73 contributors on GitHub, so it's actually a pretty big project at GitHub. And we've had commits from a number of vendors, like a dozen universities and some individuals as well. So it's been done in the community. You can see what we're doing as we're making commits. And you can try this out running any of the languages that supported by the JVM, but also supporting all the Node languages, or JavaScript stuff. And you can run these things in the database. We released that last fall. Or you can run it in MySQL. We'll talk more about that next week at Percona Live, which is the big open source database conference. And we just launched a few minutes ago, grailvm.org. We have a lot of documentation and downloads there. And then when you get something running, you can debug this stuff with Java tools like NetBeans, but you could use JavaScript tools like Chrome, and it'll work on any of the GRAIL VM languages. Please join us, on GitHub if you want to help commit, or come to the website and see more about it.
That's wonderful, Eric. Thank you so much for being here. And this sounds pretty cool. This whole thing of write once, run anywhere. Now it's like write anything in any language and run anywhere. So that's wonderful. Thanks a lot, Eric. And by the way, Eric, the performance on Twitter, what was the improvement in performance on Twitter?
Oh, thank you. It's 11% faster. The open source version of GRAIL is 11% faster for Twitter than it is with the previous version of the JVM.
Yeah, so Eric said 11% faster. On Twitter, the performance is 11% faster, and that's why they're using GRAIL VM. So if you want to drive for better performance and you have scale of workload, that's a good alternative. So no more pressing off that circle button for you. Okay, great. So graalvm.org. So with that, let's get into what we wanted to share with you about serverless functions, etc. We're going to work on this scenario of selling a car. And I happened to be walking in the Oracle parking lot and took the photo of Larry Ellison's car. He has a particular spot. And actually, there is a security guard that is watching. So if you ever park there, within about 30 seconds, someone will be on you saying that's not your spot. It's a Lexus LFA, so it's a pretty expensive car. And so I said, hey, why not try and sell that car? Now, don't tell him I actually sold the car, otherwise I might not have a job after this keynote here. So, and someone loved cartoons, so here's the cartoon of the scenario that we're going to walk through. So if we go through the various stages of this, first, I'm going to show you a bot that's actually going to put his car for sale on a blockchain. I'm going to show you how a chatbot is built. So the interaction paradigm for the selling of the car and the buying of the car is done via bots, chatbots, on Facebook Messenger. So I'm going to show how that is built. And then we're going to have chatbot creating Carfax requests, putting the car onto the blockchain, et cetera, using serverless functions-based calls. So we're going to walk through, Matt Baldwin is going to come up and talk through functions. And then finally, we're going to look up on the blockchain as to what cars are available and be able to buy the Lexus MFA. So that's the scenario. So and this is the architecture, which is not cartoonish, though it does have some cartoon elements to it. I'll show you in a second. But so the customer, that's me, is selling my car. That's the Lexus MFA. And we used the Chatbot Platform from Oracle as part of the mobile cloud to be able to interface with the customer. And then the part in the middle, I can use this guy here. This guy here is an event-based Kafka engine that we built. And then finally, you have functions-based development, so you have serverless programming. And then this car, there's the cartoon part. This car is then put onto the blockchain network. That's the one in the middle. And then from the blockchain network, we're able to purchase the car also. So a different dealership is able to, for a different customer, enable them to buy the car. So that's the experience out there. So let me just show you what the experience looks like here. Let me just go to my mobile phone, if you guys can plug this in. So here we go. Can you guys see my iPhone? If the folks can put up my iPhone here. The folks in the front or the back, my iPhone, please. There we go. OK. And yes, I have a few emails to read. Please do not comment on that. People wonder if I'm doing work or not. But let's go to Facebook Messenger here. So this is just me going to Facebook Messenger. And here I friended John's car dealership. And I just say hi to wake up the bot here. So this is just no education needed on my part, no read the manual, no book needed. And here it says, welcome, Siddhartha. Are you interested in buying or selling? I want to sell Larry's Lexus MFA. That's great. We offer competitive prices for clients, so it knows who I am. So can you upload an image? So I go in here. I go to my thing. Looks like I've taken a lot of photographs of his license plate. Not sure why, but here we go. It's asking for a license plate. So now it's doing optical character recognition on the license plate. Can you upload recent pictures of the car? And here's the actual picture of the car. And this is his actual spot. That's right in front of the 500 building. That's his actual car. So that's why I'm a little worried doing this demo. But OK, it's already done some parsing, figured out some details. I'm going to look at a few more details out here. So it's gone, look up maybe Carfax report or something, got some information, navigation system, 7 speakers. That looks wonderful. And the mileage, so let me see, is this correct? I say yes. And the one thing that it asks me is what's the mileage on the car, because I can't get that necessarily. Now, I generally drive between 150 miles to 180 miles, and I can only do that on the 280 close to San Francisco between 2 and 4 a.m. on the night. So I don't really drive that much. So that's 1,100 miles so far. It says, so it's looked up Kelley Blue Book and says, Kelley Blue Book values the price of your car to be $375,000 today. And since it's great condition, I'll buy it for $385,000. That's kind of a bummer because these cars are supposed to appreciate in value, and I thought this was supposed to be $425 and I'd be making some money. But oh well, $385, what's another $15,000, $20,000 when you can buy cars like this? So I said, is this okay with you? Yes. So there, we'll continue to process the vehicle and send you the documents for the transfer. So that's the kind of interface that can be built, and we will need this a bit more later. But let me just put this here for now. So talking about, if we can go back to the slides, please. There's a pretty significant transformation that is happening. We're moving forward from the app era. Everyone was building mobile apps, but now chatbots and messaging are becoming the key form of interaction with embedded AR, VR capabilities in there. So image recognition is built in as you're doing chatbots, and virtual personal assistants are going to be taking over. If you think about your mobile phone, what's the most popular app on your phone? I have 2 kids. My daughter's almost 17. I was actually in Boston just 2-3 weeks ago showing her colleges out here. And I have a son who's 13 and a half. They live by their phones, but they don't have voicemail set up. How many of you have kids? Yeah, and how many of them have phones? Pretty much everyone. And how many of them have voicemail set up? No one. So they don't use voicemail. Email. They only get to email if I force them to use email by saying, you have to go look at that because it's something important from school. The way they all communicate is messaging, either Facebook Messenger, Instagram, Snapchat, iMessage, etc. So the paradigm of conversations is moving towards using AI. And when you think about if you wanted to build that kind of a bot interface, what are some of the challenges that you have? One, there are lots of channels there. There are 2 sets of channels. One is the input channel, which can be Alexa, Google Home, etc. The other is the app platform upon which you're working, which is Facebook Messenger, WhatsApp, WeChat. So you now have to integrate with Alexa. You have to integrate with Facebook Messenger. And then you have to have natural language processing. What did the person say? You have to understand the intent of what was being said. So you have to use AI techniques in there. And then you have to have security, back-end integration. So for example, I might be needing to go to some back office applications to get some information on maybe the policy or insurance capabilities of the car, et cetera. So there's a lot of work that developers have to do. And so how do we make it simple? And this is actually, I've done the demo here of the chatbot. What we did was we built a platform to be able to help developers to build the chatbots easily. So first, we built the integrations into Alexa, Google Home, et cetera, so that we're able to take the voice to text. They give us text. And then we've got a natural language processing engine. And that natural language processing engine goes in and understands what happened, what was the intent of the conversation, and then what are the entities upon which that we need to act on. For example, here an entity might be the type of car that we're working on. So we built that. And then you saw the interface. I was able to load in cars and things like that. And if I were to say, show me all the cars available for sale, it would use the Facebook Messenger card layout look and feel. So we've even integrated into the UI of the messaging platform, so you as a developer don't have to worry about this. And then we've got deep learning algorithms that are built in so that we're maintaining the state of the conversation. What did the person say? Did they say something that indicates that they might have reached a decision, or is the tone of the conversation heading south, in which case we should transfer that conversation over to the customer service rep, right? So that's all been built into the platform so that you can build these bots pretty easily. And I'm going to switch to the UI of how to build bots. So let me just go in here. So browser, where's the browser? Matt, where's the browser? Here we go. OK, let me make sure that we're logged in here. So this is the mobile cloud from Oracle. And this is the bot piece of that. So here, for example, you can see from mobile cloud, you can build mobile apps, native mobile apps with mobile backend as services like push notifications, storing securely on local drives, et cetera. You have the ability to build visually developed apps where without writing a single line of code, you could write a mobile app that can run natively, run as mobile web, et cetera. You can build bots. That's what we're going to spend time on. You can do analytics. You can get insight into how the application is being used, whichever application it is, whether it be a bot, whether it be a native mobile app, etc. So let's go to the bot here. And I'm going to go to the car dealer buy bot. So these are bots that I'd built. And here you can see there's notion of intent. And as a developer, what you're doing is you're asking the business user, what are some of the intents that you have? So here, the intents that maybe people put in was buy a car, I'm looking for a car, I want to buy a car. Now, there's no way that you can put in all the intents. And so that is where we're using machine learning. So here, for example, we've got different models for machine learning that are built in here that can be used to train this bot. So let's play around with this bot a little bit. And here, I want to see, I want to test the intent, like buy Lexus. Okay? Now here you see there is no notion of Lexus. But when I say buy Lexus here and I say send, this is actually in the build environment. So I'm testing what this looks like. It actually comes back and tells me, here's the confidence with which intent was the person trying to execute on. So buy car is the intent with 30%. And if, for example, I want this buy Lexus to be added in here, I can add that as an example, which then results in retraining the bot such that the confidence level is going up. And if you had a number of conversations that you'd already recorded your customer conversations, you could actually stream those customer conversations in, and we'd be able to learn from the bot. And if we went here, and if we said, this shows you what the response would be to an end user if they were interacting with this bot. If I said buy a car, now it's actually executing the code that shows you what the response would be. Right? And here, this is the interface that is showing you. If you were doing it on Facebook, it would look different. So you have the notion of intents that we figured out based on just some hints that you've given, and then we keep on learning on an ongoing basis. And then we have the notion of entities. So entities are address, currency, date, et cetera. These are system entities that we've created so that from the conversation, we can pull out things like address or currency. If you're doing a bank account transfer and you say, pay mom $50, and you'd ask, before, what's my balance in checking, we no longer ask you which account you want to transfer from, and we're able to pull out $50 as currency out here. But you can add your own custom entities also. So in this case, I've got dealer as a custom entity, and here I could add, for example, name. So based on which dealer, you might have different dealers that you're working on, okay? And then what we've done is we've created these bundle packs, resource bundles. So we already have multilingual natural language processing in there. But if you have a better way to process, you have a resource bundle that you want to use, you can integrate that resource bundle in here. And we've also got here the ability to have custom components. So in this case, if you wanted optical character recognition, and you wanted to integrate optical character recognition in here, through a webhook, you could actually call a particular OCR package that you have. And then here, you can see the channels that are available to you. So for example, here's the Facebook channel. And we're already enabling secure single sign-on, three-legged OAuth, et cetera, for you, so making it really easy. And then we're also giving you the ability to use webhooks to add other channels. So the goal of this was to show you that as a developer, it becomes very easy to be able to actually build these bots. And we're giving you a visual drag-and-drop paradigm of how to lay out what the conversation might look like based on what kind of decisions made by the engine, what you might want to happen, right? Like buying the car or putting the car on a blockchain. So here's the overview of our platform. One, we're giving you cross-channel integration across both Slack, Facebook Messenger, WhatsApp, Siri, et cetera, plus on the voice input side with Google Home Alexa. Dialog flow execution. So you have a declarative builder, which I showed you. You're building the bot declaratively as opposed to writing a whole bunch of code, and it has a state machine built in. So for example, if I was looking for a new laptop to purchase as an employee, and I saw the 3 laptops, and then I said, yeah, I'm done with this view, it knows to ask me, well, have you made a decision? Because it's maintaining the state of the conversation. And then it has the conversational AI engine in, which is using machine learning to be able to learn on an ongoing basis. And really importantly, it also has integration to backend. So we make it very easy for you to be able to integrate with backend SaaS applications, back office on-prem applications, with making very simple API calls, and we do the integration with the backend. So with that, I'd love to bring Matt on to talk about serverless functions.
Thank
Matt,
you.
where does serverless fit into this whole paradigm here?
Well, it's actually kind of, actually we'll go to the next slide and kind of fit where it fits in. Where it fits in, Siddhartha, is that where we have this Kafka event engine that actually is kicking off events, and then we have these serverless functions acting as almost like microservices or nanoservices talking to the blockchain architecture. And so that we can talk to it and spin up something really quickly and then tear it back down real quickly. So it gives us scalability as we add more dealers and more participants and organizations to the solution.
Great.
So let's kind of kick off into what is serverless. And so what is serverless is, yes, let's lay it down flat, is that there are servers there. Okay, everyone, there's servers there, and lots of servers actually. But what's important about serverless is that you don't have to manage the cruft underneath. You're just writing code, you're building things, and the serverless components are all being managed for you. And so that is important for a variety of different reasons. And what we're going to talk about today is about functions as a service, and really functions where as a component, it's really the kind of the runtime, the infrastructure that we'll be talking about underneath. So why serverless? Why do we have it? And so first of all, it's just very simple. It's cheaper. Because if you're looking at a traditional application, say you stand up a Jetty server, Tomcat server, when you stand that up, you then run that for a period of time, and you're constantly running it. And there's a cost associated to that. What we can do from an economics perspective is that we can say, let's just run that function for a moment and then move on, and then tear it down, bring it up and tear it down. For example, we can also make it hot, so it can be up for a little bit and then torn down after a period of time. The next point is agility. Agility is key when we're building new applications. How we want to reduce the amount of code that we're actually developing, and we want to be able to not introduce errors into the code that we're building. And then reliability is that we're not managing the service. We can offload that management of that service to the cloud provider. And so that gives us reliability, the patching. We don't have to deal with operating system updates or patches or any of those things. And then finally, innovation. If I can write code and kind of think at the speed of light, where I can innovate faster and I can compose applications in a much more efficient manner and deliver overall value to the business much quicker. So it was announced in Oracle Open World 2017 is the fnproject.io. And what the fnproject.io is, an open source project. It's tied to the CNCF, the Cloud Native Compute Foundation. And what it is an open source project that delivers functions as a service, where you can deploy this capability on premise, and then we will be offering a functions as a service capability as a managed service as well. But the key thing here is that you can get started today building functions that are portable. And with the underlying technology being containers, and it's just a really exciting project, because when we look at, we have 50 committers now, 50 plus Oracle, non-Oracle committers to the project, so it's a very active and dynamic project. And there's also 2,500 commits, actually 2,500 plus commits that have actually been committed to the project as well. This is very exciting, great investment, and really kind of gets you going and thinking about how to build functions, and with multiple languages as well. So let's look at what is a function. So functions, the function project takes the basic concept from 30 years or 40 years ago when we were building Unix streams in and out, very simple. So you put something in, the black box, that function, and then something comes out. And so and then we have, you know, basic output to standard out, and then logging to error. The function server and the function service handles everything else, like the API gateway, piping things about, storing calls, logs. It takes care of all that cruft underneath. So it's a very simple, very elegant solution in terms of how to how you're going to build your, you know, that nano service underneath a microservice. And then when we start looking at the CLI is very straightforward. FN init creates an app. It builds a scaffolding for an app. In this case, FN at runtime go, FN run, FN test, FN deploy, FN call, and then we basically build routes. Everything when it's deployed is a REST service. So all you have to do is be able to say, okay, FN deploy, and then that route comes forward. But really kind of enough of that. Let's kind of walk into some of the code. So
effectively, this is really portable across multiple environments. You can run it on your laptop, you can run it in our public cloud, you can run it in a third-party cloud, and you're not just locked into running everything in one cloud, right?
Correct, absolutely, correct. And let's do runtime. Typing is good. By the way, this is pair programming. I'm one pair, you guys are the other pair, so you can always help me if you want. And runtime go, and we'll call it hello. So what we did there is we built a basic scaffold of a function. So we'll cd to it. And what you see are three artifacts, really, three key artifacts. The service itself, the actual function itself, func.go, func.yaml, and test.json. So let's take a quick look at these. And let's look at that func.do. Let's make this a little bigger. I mean, nothing really special, but what it is doing is using basic standard in, standard out. So you can see right here saying we're looking for the person name, and guess what? It's a hello world kind of capability. And then the func.yaml actually defines what language it's going to be, where the entry point is, and then the test. We also build a basic testing for a black box testing on the environment as well. So let's go back to here. So the basic, simplest thing we can do is function run. And what it's doing here is it's basically building a container, and then it uses that container and says, hello world. Awesome. But now let's see what's actually, so for those who are doing verbose, here's what it's actually doing under the covers. So in other words, it's doing all the things in terms of building, in terms of using and leveraging a container, but you don't see any of it. So for those of you who are interested in doing something like this, right, like I'm using a MacBook, you can do a brew install FN, and you'll get the function development kit, and so it's part of brew, so you can use that. So now let's try something, because we said, what is it, standard in, standard out kind of thing. So let's do echo, and let's call it like this. Let's write some JSON, and we'll call it that, and we'll call it Boston Strong.
Yeah.
There we go. And there. And then we will pipe it to FN run. Now with all luck, it's going to build the image here and say FN and then FN run. Oops, what did I do? I must have an error here. There. There we go. It was just an error. Come on, I need your help a little bit here, guys. You can give me a hand here. So okay, so that's actually building that. But then what we want to actually do something more with this. This is running inside of my development environment. See, it's very elegant, very straightforward. We just manipulate the Go code. We can run function start and function run and build right just like that. And we can even do a function test, for example, like that.
We need to speed it up a little bit.
And we'll do a function test, and it's running the test cases. And then we can then say, okay, so let's actually deploy this. So do deploy .app demo hello. Okay. App demo. Oh. Local. Okay, function deploy, demo. App, okay, just make sure I got this right. App demo. There. Okay, so what's doing here is that's actually building a new container. And what it's doing is then publishing it to a service, so we can say function apps list. There. So now we have demo deployed, O-code deployed, and then what we can then say is we can say routes list demo. And see, that's the endpoint, because now we have a routable endpoint that we can use. And so now we can say curl, right? And we can say curl, and we'll say HTTP. And my mouse is somewhere here. And we can see that. And so we can also, so that's actually deployed on a server. It could be deployed as function as a service, server as well, from function as a service. And it can be deployed. And we can pipe things in and out of it just like we did, like we did before. So that's the basic concept of what function is from a CLI perspective. So let's go back to the presentation, because when we're looking at more complex things, we want to be able to provide some level of orchestration for those functions. So, and particularly for longer running type of functions, and want to do additional parallelisms. So what we've done is then we've leveraged the completable API from the Java 8, and to allow us to build these parallel functions, and so that you can build some very complex orchestrations. So, for example, your boss comes up to you and says, sell car is kind of the microservice, but it actually has a variety of things underneath it, such as I want to have a Carfax report, I need a criminal lookup, I have an FBI lookup, I have all these different little things that make up sell car. And then I'm going to write that to the blockchain once that's all complete. So I'm going to take the completable futures API, and we can pull all that together into an orchestration. So that orchestration then looks like, okay, here's the current flow. It's a little bit long, a little bit dense, but the point is that you can build this in terms of getting cars, and then those get cars are going to process the car, so I'm going to get some particular data, and that particular data then is going to drive down into, get the Carfax, get the criminal lookup, and then finally come to the end and do a print line to the end. So flow is the capability of taking many functions and then kind of orchestrate them into a series of events. So let's kind of walk into
we need
here.
To speed it up, Matt. Running short.
Okay, and alias, so what we have here. And so I have a quick alias, I'll code flow. And what's that doing is actually running an execution. And so you can see the execution of these APIs actually, and these functions actually going. And so we can then drill down and see how fast and what they're doing all the way to the end, and as they complete. So what this does is it gives us, so everything from code get cars, what it does, it gives us kind of a trace route all the way through the execution code. Then the next step is saying that's the positive step, but then there's also it helps us in terms of debugging. So just to kind of finish up here, coming as a service based on upstream FM, we're going to be delivering functions as a service. Second, it'll obviously be integrated with Oracle security solutions from end-to-end protection. And then, as you can see, all these functions have an API driven associated to them. And we're going to be integrating tightly with our API platform so that you can build mock services, and then as you build your functions out, complete them. So, Siddhartha,
yeah,
here you go.
And the next one is going to have to be really fast. That was wonderful. Matt, stay on stage. Matt, stay on stage. Yes. So the differences here with AWS Lambda, for example, is that you can run it anywhere, not just on the cloud platform. And two, you can write the programming language. You can write your containers in any language. The function flow chains everything together. And then lastly, oh shoot, I forgot what I was going to say. But okay, we go to blockchain now. So on blockchain, just real quick, in this architecture, we're now going to talk about that function placing that car onto the blockchain network. So let's just talk, and then the person on the other end actually buying the blockchain. So what is blockchain? It's a system for managing distributed ledgers in a peer-to-peer network, which means that not everyone is fully trusted, but you have many players who want to be able to do a transaction. And today, the reconciliation of those transactions is all done via emails or Excel spreadsheets being exchanged. For example, you have a manufacturer who then ships the good via a shipper. The shipper then delivers the goods through customs and over to the end person receiving the goods. There has to be validation across the board, and today that takes a lot of time. So now if multiple parties can actually transact on a blockchain, you have transparency the minute the transaction is done, because the transaction is immutable, which means it cannot be changed, and that there are at least 2 or 3 people who've endorsed the transaction, which means the transaction actually happened. So if you look at some of the key use cases that we've seen, this is where I was talking about everyone's thinking about use cases. We have financial services-based use cases. We have supply chain-based use cases. I just talked about the supply chain with the shipper. We have public sector-based use cases and healthcare-based use cases. And one of the use cases that is becoming very popular is identity. How can you have shared identity so that, for example, the government of Canada is saying that if you set up an identity with a bank, then you don't need to recreate your identity when you go to get a new cell phone account with T-Mobile or whoever it might be. They can actually share identity by requesting off a blockchain if this person has an identity that's been well authenticated. So less work for the consumer, less work for the authorizer on the front end. If you think about the patterns for blockchain, you can enable distributed autonomous marketplaces like the identity case, reduce friction, so that's reducing the amount of effort needed, the time needed for reconciliation. You can securely maintain and share the decentralized records like identities, and very importantly, track the provenance of documents. Provenance means where was this produced, what were the goods used that were produced. So for example, for my Lexus MFA, I want to make sure that when I'm buying the car, not only do I know, yes, the car is there, but also that it was always taken to a Lexus dealership. Where were the parts purchased from? Were the parts original parts, or were they not original parts? I want to know all of that about the car, and that could be put on the blockchain. And if you think about challenges in terms of when you're thinking of writing blockchain applications, is that one, you have to figure out how to integrate with supply chain systems. You have to integrate with back office applications. You have to integrate with identity systems. So it takes a lot to do that integration. And production readiness. Blockchain is not easy. It takes a little bit to scale as the chains get longer, performance gets impacted. So how do you make sure that you can have a high-performant, secure, permissioned blockchain that is running for you? And also, technology is changing really, really fast. You look at MapReduce, for example, on the fast data side. That was the technology 2-3 years ago. Now it's all Spark. So how do you insulate yourself from these technology changes where Hyperledger Fabric is just in its version 1.0? And then operational challenges. So when you want to set up this network, how do you bring on members? How do you monitor what's going on? How do you support and lifecycle management for this entire blockchain? So what we've done at Oracle is we're delivering blockchain as a service, and Matt's going to demonstrate that, which makes it very easy for you because we're using Hyperledger, and we're giving you an implementation that is extremely secure and scalable. We, in fact, took the team that was working on our Tuxedo application, which is a distributed transaction management application, and I've been able to leverage that team to make sure that we can have a highly scalable distributed transaction mechanism. So now you can just come and say, I want to implement my use case, use a couple APIs to be able to execute transactions onto the blockchain. And that's what Matt's going to talk about. And it's running on our infrastructure platform, which is giving you a lot of high performance built into it. So Matt, if we can do a quick demo, and we do need to move fast.
I certainly will.
Yes.
OK, so first of all, what we're going to do is do a quick close out of here. So, and say, because now we got to buy the car. We're actually going to buy the car back. And so we're going to buy the car. And it's relative to the blockchain discussion. So you saw this with Siddhartha, we have different cars that we could choose from. But let's say if I want to say I have a Lexus, I'd prefer to have a Lexus. What we're doing here is that we're searching across the blockchain and saying, oh, I don't have one in my dealership, but I may have one in another dealership. And so that's the key thing. It's finding this new car. So we can prove that that's the right car. And then I can say I'd like to purchase it. So we're committing a transaction on the blockchain network at this point. And so we can say, hey, wait a minute, it's $399,000. Somebody made a markup. And what this means is that it's permission between two dealers, so that we can look at what the two dealers are actually talking about, and only they are involved in that transaction. So I'm going to say yes, I want to confirm that. And so we'll complete the transaction, we'll do the paperwork, we'll go to the dealership and take care of that. But the other piece of this is that this is an application for the blockchain network, right? And so we can also build other applications that are associated to this. Both of them are using what's called the REST proxy. So as a developer, from a developer perspective, we want to do 6LIC 274, I think is the car. We can build custom applications on the blockchain using a REST proxy. So as a developer, there's three things that you're going to be doing. You're going to be developing applications which are outside of the blockchain, and then those applications will interact with what's called chain code. And chain code is usually built in Go, and soon in Java, is that it'll be built, and that is the contract that builds consensus on the transaction on the blockchain. So the key thing is, what you're seeing here, this is a custom app, and we can see that the transaction has occurred, and you can see several transactions, part of the testing we've been doing, and also what are the API details. And this is showing all the detail of the transaction that's occurring on the blockchain. So this is a call, that's the REST call.
So that was a sample application that was using the same API call that your bot was using.
Exactly. So we build multiple applications accessing the blockchain and accessing the chain code. So from the network perspective, we have multiple networks here. We have one network, then an originator. And this, we can then say, what does this network look like? And this is how the blockchain, we can visualize the overall blockchain. We can say there's organizations, there's a founding organization, then there's multiple organizations in that blockchain. And then there are peer nodes, and these are the green things. And those peer nodes basically process what's going to be happening on the Hyperledger fabric. And then finally, and before we kind of go off and finish up here, is that we have the concept of nodes. And this is what is key, it's important. Think of what nodes are in blockchain, and particularly the Hyperledger fabric, is that these are subnets in terms of organization A talks to organization B, and only organization A can talk to organization B. And so we can set up these subnets. So for example, the difference between Bob and John's blockchain is that I don't care about what other parties may not need to know about what price was paid for the car, may not need to know about the shipping and how that car was shipped to the other dealership. In other words, we can do this in a permissioned manner, leveraging channels inside of the Hyperledger fabric. So I'll kind of stand down from here and go back to the presentation so we can keep us on schedule. And so basically on the left-hand side, the key things from a developer perspective is you build really through two key things. One is on the left-hand side are the applications. And so, whether it be a chatbot, whether it be a trace application, and then you define the network, which is in the middle. How do these channels work? And then you define what the chain code is going to do. And that's the most important piece. That is the smart contract. That is the piece that actually builds the consensus that you're going to install onto the blockchain. And on the right-hand side, we're adding value in terms of getting administration console, a REST proxy, and these other capabilities, and really hardening the overall Hyperledger fabric. So, Siddharth?
Great. Thanks a lot,
Sure
Matt.
enough. Thank you.
That was a great demo there. So we need to work hard on leveraging the APIs and then using or writing the smart contracts. In this case, it'd be putting the car onto the blockchain network. So just to wrap up really quickly about our application development platform, we've shown you some parts of it, but we've got an entire CI/CD pipeline so that you don't have to set up Jenkins or Jira, et cetera, if you don't want to. But if you have Jenkins, for example, continuous integration, you can easily blend it in. We've got Maven already built in there. In addition, the CI/CD pipeline understands containers natively. So when you, for example, check in code, and we know you're going to write a container-based application, we'll automatically build a Docker image. The pipeline knows that that Docker image needs to be registered, and that it could be put in a public registry or in a private registry, and then be able to deploy that as a container onto a Kubernetes-based platform. We're providing you Kubernetes as a service so that you don't have to worry about spinning up Kubernetes, maintaining Kubernetes, scaling Kubernetes, et cetera. Your containers automatically get deployed onto Kubernetes. Or if you want, you can say, I'm just going to bring my code, and I'm writing the code in PHP, Ruby, Go, Java, it doesn't matter. We actually manage the runtime for you, where we're running it on containers, but you're not aware that it's running on containers. So either you can be container native, or you can just bring code, and we can run it on containers for you. And then we talked about the mobile cloud capabilities, the chatbot functionality, plus all the mobile backend as a service capabilities, and the integration to the backend applications. The API-first development, you should check out apiary.io. So that is a place where you can go and write documentation, and that creates an API. That API is actually running on a mock server, so that without writing the implementation of that API, you can actually go to someone who's going to use your API, get them to use it, collaborate on what the actual contract should be. Once you have that contract agreed to, then you can go and implement the API. And then we're giving you lifecycle management for the APIs, so that from build to test to run, et cetera, you've got insight into the performance of the APIs. You've got an API gateway that gives you security, so validation, authentication, rating, throttling, et cetera. And that API gateway can run anywhere. So it can run in your on-premise application environment, it can run in the Oracle public cloud, or it can run on a third-party cloud. So an entire API management platform with a portal to expose to developers who are going to consume your APIs. Obviously, if you're writing in Java and want to use WebLogic, we're delivering WebLogic delivered as a service. And then finally, for those folks who want to do rapid prototyping and be able to build applications where they're not writing code, but they want to work with the line of business users, show them what the application could look like, we're actually giving you a visual development environment where with drag and drop, you can build out the application very easily. And then it can generate the code for you from that visual developed environment, and you can extend the code from there. And this is what all our platform looks like. We talked a lot about the front-end tooling, the API design, and the visual development capabilities, the back-end services with functions, chatbots. And then I didn't talk a lot about the performance management capabilities. So from the cloud, we're able to monitor and manage your applications where you don't have to, where we've created one consolidated data platform for log data, performance data, user experience data, config data, and we're applying machine learning to this data because we've got tons of data and we've got tons of compute capacity in the cloud where you no longer have to tell us what thresholds to set. We learn the thresholds over time. We learn the server topology over time. So now you don't have to monitor and manage your on-premise monitoring management infrastructure, and you don't have to spend time setting thresholds, et cetera. You as developers can get real-time feedback into what's going on with the application. And then the Event Hub Cloud Service, Kafka, giving you scalable Kafka clusters. You being able to leverage the eventing, but you don't have to worry about the infrastructure and the scaling when message storms are coming in. Identity, being able to do single sign-on from your application to other applications. And then integration, being able to very easily integrate your applications with back-office applications. We're giving you adapters to various SaaS applications and on-premise applications. And finally, data stores, you don't have to just use the Oracle database. We're giving you MySQL delivered as a service. We're giving you Cassandra, NoSQL delivered as a service. And if you want, you could even run MongoDB on our IaaS. And all of this is running on a very performant, highly scalable, secure IaaS platform. Lots of traction for the Oracle Cloud. The analysts are rating us at the very top in terms of Magic Quadrant and the Forrester Waves. Lots of apps in the cloud marketplace. And then for developers, go to developer.oracle.com. And that's the place where we're putting all our content for developers. You can see blogs. You can see the content on containers, APIs, DevOps, tooling, et cetera. So thank you, and would love to get your feedback. We'll be around if there are any questions. We can take those. Rex?